As localization experts, we are used to juggle a multitude of tools, largely also so we can meet the diverse needs of the various content types of our stakeholders and clients. The last decade has seen continuous development find its way in pretty much every industry with localization need, which subsequently made it a priority for us to look for agile and automated tooling setups. Thankfully, developers have set a standard for creating connections between different systems, and many of our tool providers are offering it. Of course, I'm talking about API. 3 letters that seemingly promise to solve all of our integration issues. So, if the solution is so easy and seamless as advertised, and everything can be connected, we should be in a golden age of total integration, right? Then why do we still frequently find ourselves stuck with database dumps, CSV exports, and spreadsheets? In this video, I'm going to share my non-techie perspective on opportunities, challenges, and the reality of working with API for localization projects. To have some fun with the topic and get a bit more practical with it, I came up with an API-driven do-it-yourself automation project that involves some of the currently trending developments I'm sure you will appreciate. The results might not be mind-blowing. The method might even be controversial, but hopefully it's interesting or at least entertaining enough to spark that inner developer in you and get yourself going to give it a shot yourself. Okay, let's start by me describing what I feel is the reality of many localization peers when it comes to the usage of API and what ultimately sparked my ambitions to get more proficient with it. Within a corporate setting, API integrations are often used by only a small group of a tool's user base. This is mainly because using API functions needs some level of coding skills to make request calls in the first place. On top of that, there's no suitable place for running these scripts or codes as they are not part of any existing ecosystem. For example, many localization tools have this neat extra functionality that would be incredibly useful for automating the creation and consolidation of language subtasks. However, even if I managed to write the backend needed to issue that request, where would the exported file be saved? In contrast to our developers that work on our games and apps directly in the repositories, in localization we are often at least one step removed from that root server and don't run a spare for saving API data. Also, the level of admin access needed to get internal tools play nicely with external tools through API bears the risk of affecting other departments' workspaces. If you ever try to negotiate with a sysadmin of a Jira-first company, you will understand this right away. It is really tough to get any template changes implemented as people are afraid of them affecting custom screens and custom fields of other teams, which is why they expect to see a well-thought-out feature description for a request before greenlighting any change. Tricky if you're not entirely sure whether what you want actually turns out to be what you need. Most likely you will want to adapt and optimize it several times. I think often there is a mismatch between the expectations of tool providers and internal development teams towards another. Tool providers assume that the user will create the necessary scripts or automations to connect to their API, while internal development teams feel it's the provider's job to make sure their tool works well with other systems. So this can leave internal localization teams stuck in limbo between them. In my career, there have been many moments when I had this great new localization or content management tool, only to discover that I depend on additional development to really use all of its features. Eventually, I got impatient enough that I started to look into what API connectivity actually means. Couldn't be that hard, right? I think this is a perfect point to do some due diligence and at least crash course through the basics of the term with the help of tech blog Fireshabelle.
An application programming interface, or API, is a way for two computers to talk to each other. Using an API is just like using a website in your browser, but instead of clicking buttons and filling out forms, you write code to explicitly request data from a server. For example, we could visit the NASA website to look at asteroids, or we could use their REST API to request the raw JSON data that is shown on the screen. Now, most APIs in the world are RESTful, which means they follow a set of rules or constraints known as representational state transfer, which has been the de facto standard for API development since the early 2000s. A RESTful API organizes data entities or resources into a bunch of unique URLs, well, technically not URLs, but URIs, or Uniform Resource Identifiers, that differentiate different types of data resources on a server. A client can get data about a resource by making a request to that endpoint over HTTP. The request message has a very specific format. Most importantly, the start line contains the URI that you wish to access, which is preceded by an HTTP verb or request method. which signal your intent with the resource. A GET request means you just want to read the data, while POST means you want to create a new resource. Patch is for updates, delete is for removing data, along with a few other methods beyond those. Below the start line, we have headers, which contain metadata about the request. The accept header can tell the server you want the data in a specific format, or the authorization header can be used to tell the server that you're actually allowed to make that request. Then following the headers, we have the body, which contains a custom payload of data. The server will receive the request message, then execute some code, usually to read from a database, that can then be formatted into a response message. The top of the message contains a status code to tell the client what happened to their request. Codes at the 200 level mean that things went well. At the 400 level, it means something was wrong with your request. And at the 500 level, it means that the server failed. After the status code, we then have the response headers, which contain information about the server. That's followed by the response body, which contains the data payload and is usually formatted in JSON when talking about APIs. Now, an important part of this architecture is that it's stateless, which means that the two parties don't need to store any information about each other, and every request-response cycle is independent from all other communication.
When I started looking into the subject matter, I went in with my usual trial and error approach, which eventually worked out, but was also needlessly time-consuming. So do yourself a favor by trying to get a basic understanding of the most important API components mentioned in the video. Endpoints, or URI, which are the destination addresses of your requests. Request types, for example, whether your request will send or create data. Response code. Just remember, 2 is always good, 4 and 5 not that much. Always keep in mind that each API request on its own is essentially a one-way street. And of course, the header and body structure of HTTP requests and the JSON format that often goes along with it. I think a great way to start is to look at the documentation for tools you frequently use, so you can check if you can create an automation for a familiar function via API requests instead of having to use the front end. As you might have noticed already, they all have API documentation that structurally looks kind of similar. Request method and endpoints are listed alongside some examples for its application. It's all put together in a way so you can get started with an on-hand trial yourself as soon as possible. The very best API documentation contains something like a sandbox, as you can see here, where you can test your calls right on the documentation page. API calls are issued by a script or some kind of automation that resides in your app or is hosted on a server. Essentially, they need a place to live. However, having to host a supplemental environment can be a significant hurdle to consider. As a workaround, sending API requests via one of the many helper services can eliminate this dependency while obviously allowing your project an easy no-code kickstart. Commercial solutions include IFTTT, Make, formerly called Integromat, and the Omnipresent Zapier. But there are also open source projects like N8N, a self-hosted platform with a very active community I make use of myself quite often. These easy-to-understand drag-and-drop automation workflow builders advertise out-of-the-box solutions for pretty much anything. They don't do any magic though. Always keep in mind that anything that can be achieved via these services can in theory be achieved without them, as they use the same public API connections available to anyone. When starting your API project, it is important to define a set of ground rules your initiatives must adhere to. First off, you need to determine your goal. It's crucial to clearly define what you want to achieve with your API project. Are you looking to streamline your workflow, automate repetitive tasks, or perhaps facilitate communication between different software? Having a clear objective will guide your decisions and help you stay focused. Next, you need to select the required API to achieve that goal. More often than not, you will use a combination of multiple API, so make sure to collect all the basics we covered earlier, like endpoints, request types, response codes, authentication, and so on, from the documentation pages for each of them in advance. Then select a suitable platform to run your API script or automation on. If you prefer using one of the commercial services mentioned earlier, you need to carefully consider your budget, as they don't come for free. Costs for an API workflow with a lot of steps and data can quickly pile up. I suggest using these services only until you have fleshed out your workflow. You can then approach your developers with clear expectations for implementing it for the long run, which subsequently will make it a lot cheaper. Finally, you should settle on a format to present and learn from your results. API projects often fly under the radar, so it's essential to demonstrate the value they bring by creating a presentation or report that informs your team or stakeholders. I think by this point we got everything covered to get started with some on-hands action. So why don't we? First, we need a compelling use case, something relevant and interesting that requires API usage and cannot be achieved with any existing out-of-the-box solution. Looking at what's dominating the headlines of the tech industry these days, finding a subject is easier than it has ever been. What could be more relevant than API experiments with OpenAI's ChatGPT? Among localization professionals, its arrival was met with a mix of shock and awe, and I feel it sent a pretty intense jolt through the language industry as it continues to create completely new workflows and push technical limits every other day or so. I was instantly reminded of the time when only a few years ago, DeepL emerged seemingly out of the blue and accelerated neural machine translation into practicality. Now, with ChatGPT on the scene flexing its translation muscles, I cannot shake the feeling the newcomer is taunting the MT frontrunner. And obviously DeepL wants back its spotlight, so let them have a go at each other, I say. Of course, there are the established MT evaluation algorithms, and there is a lot of actual research and science going on when it comes to testing the capabilities of AI machinery. But since it only serves as a means to an end for us anyways, we don't need to be that serious with it. So I came up with this absolutely unscientific and unnecessarily elaborate testing scheme. It revolves around a simple logic. We present both machines with the same text sample and instruct them to translate it from one language to another, and another, and one more, and then back to English. And then repeat that relay translation a couple of times to compare their final English outputs with another. It's like the telephone game you might remember from childhood. The more proficient machine would obviously produce a final translation that is still closest to the original. Looks fun, right? Let's plan our API project for this. I gave the construct I ultimately ended up with a dramatic title, AI Showdown. The goal of its API control translation workflow is to give us somewhat of an indication of the machine translation capacities of ChatGPT versus the one of DeepL. It consists of three major components. The first is the Showdown intake form, which allows testers to enter the text samples and make adjustments like the number of cycles that the contestants will have to complete. The neat thing about forms is that entries can be formatted automatically by your definition, so they are ready to be sent as API content. The next component is the automation workflow. I've chosen Make as my API platform as it is not only convenient to use, but also is best suited to visualize this to you. After the user submits the intake form, the data arrives at the incoming webhook of the engine's scenario. In order to have both run simultaneously, I'm using two separate workflows with identical structure. The text sample is run down the relay, making entries to a Google Sheets for each translation work step. At the end of the relay, the automations check whether there are additional cycles to complete. If so, it reduces the cycle counter by 1 and sends an HTTP request to its own webhook using the last EN translation from the relay. If the cycle counter is at 0, the automation will conclude. You can also see that I am posting Slack messages to have somewhat of an indication where the contestants are with their progress. Originally, I used a MySQL database to save results, but didn't find a good way to reference the data from the front end, so I opted out using Google Sheets instead, which are updated by the make workflow step I showed you earlier. So with everything set up and ready, let's get started with our first showdown. Obviously, we want to see their performance with common text found in game localization. This project originated from a concept I initially planned for the game localization workshop back in May. Therefore, it seems fitting to choose a text sample from a game by Vuga, whose wonderful localization team hosted the event for the third time this year. The game is June's Journey, and I will use the English Google Play Store description text. I'm copying it from here into the Showdown intake form. The Showdown will go through 4 cycles of the French, Hungarian, German, Japanese, English relay. That's a chain of 20 translations. I'm not giving any special instructions to OpenAI and leave its temperature, which determines to which degree the AI can interpret your prompt at the default setting. Alright, then off they go. I recorded the scenario progression on Make so we can watch them simultaneously here. Seems like DeepL is off to a head start. Or maybe OpenAI opted out of the race for some reason. It barely moves. It does some progress though, and we're not evaluating who's the fastest, right? Let's fast forward. I can't say I'm surprised though. The OpenAI API is currently probably the hottest tech of the internet, and I am sure many are swamping it for far more ludicrous purposes. Nice, all done. Let's check the results sheet. Wow, that's a lot of translations. To be honest, I didn't really have a full understanding of where to take this beyond this point, or if there even was a somewhat objective way to compare all that data without a battery of translators. Luckily, solution vandals now have a new joker to pull that might bring even the wildest concepts to reality, especially if they got mainframe level analytical skills and essentially speak all the languages. Right, GPT-4? Hey, why don't you just take the stage and present what I asked you to do yourself?
What? Like right now? But I haven't prepared.
Come on, it's a real nice crowd, and they're all waiting for you. You can do it.
All right. If you say so, Daniel. Well, hi everyone. Here are our observations for this showdown, starting with DeepL. In the Hungarian translation, the phrase June's journey is translated as a June's journey. This is likely because Hungarian doesn't have articles like the or a, so DeepL might have added it for grammatical reasons, but it's unnecessary in English. In the German translation, June Parker's captivating quest becomes June Parker's fesselndes Abenteuer. DeepL changed captivating quest to gripping adventure, which slightly alters the original meaning. In the Japanese translation, I Spy a Hidden Mystery Detective Game is translated as I Spy is a mysterious detective game that you can't miss. DeepL dropped the hidden aspect and made it more of a statement rather than a playful expression. Now let's have a look at OpenAI. When translating from French to Hungarian, Detectives aux yeux vifs became Eber Semu Nyomozók, which means alert-eyed investigators instead of sharp-eyed detectives. This change in wording slightly shifts the meaning. In the Hungarian to German translation, June's journey was translated to June Parker's Aufregende mission, which means June Parker's exciting mission. The name of the game was lost in translation and replaced with the main character's name and her mission. In the last English translation, the phrase, "You too can become a detective," was translated to, "Everyone who is awake can become an investigator." This change might be due to OpenAI interpreting "you too" as referring to everyone who is awake. So what's the verdict, Daniel?
Oh no, that decision is totally up to you.
Great! Okay, so while both translations have some inaccuracies and peculiarities, DeepL's output is closer to the original text in terms of meaning and structure. DeepL is not without its faults. For instance, it changes I Spy a Hidden Mystery Detective Game You Don't Want to Miss Out On to I Spy, a mysterious detective game not to be missed. While the meaning is similar, the structure and tone are altered. OpenAI's translation has more significant issues, such as introducing government conspiracies and secrets of a grand castle, which were not present in the original text. Also, the phrase "you too can become a detective" is changed to "everyone who is awake can become an investigator," which alters the meaning and tone. In conclusion, DeepL emerges as the winner of this showdown, as its translation is more accurate and faithful to the original text. Happy?
Of course, great work. Wow, they even gave it attitude. I think I owe you some explanations about where my grumpy assistant came from. After I realized I wouldn't have the energy to go through all the translations by myself, I added a review step to the Make automation workflow. Together with a plugin for Google Sheets I found, it conveniently produces an assessment of all the incoming Showdown data. And if I wouldn't have to do tedious study of translations, why would I even have to read it? Let's give the AI a voice and have it present the results to me. So I made another automation workflow addition with the integration of the Alvin Lab Speech Synthesizer API, which resulted in the GPT-4 that just introduced themselves to you. Let's see what else we can come up with. To celebrate the release of Final Fantasy XVI from our workshop friends at Square, I picked a narrative text that describes the world the player will interact with. Without giving any additional context about origin or usage of the text, it should present a significantly higher challenge for the machines, which will also have to work through 8 relay cycles, meaning 40 translations this time around. Take it away, GPT-4.
You picked a pretty tricky text there, full of proper nouns and a high chance to miss the mark if the context is misunderstood, which the engines promptly did. DeepL started off by reducing mother crystals to mother crystal, losing its plural form and changing the meaning entirely. Meanwhile, the engine transformed icons into acon, which sounds more like a pop singer than a fearsome creature from a fantasy world. But why bother? After all, dominance is now dominator anyways, so surely no one would object. Here we have mother crystals becoming mother cross, which is not even remotely close to the original term. OpenAI didn't fare better. Icons, the most powerful and deadly beings in Valesia, have turned into acorns, which is at least adorable. And dominance has been replaced with leaders, which is definitely not as funny as dominator, but therefore twice as wrong meaning-wise. The last paragraph of the original text is omitted entirely in the final English translation. Both engines have managed to butcher the original text quite spectacularly this time around. The essence of the story is barely recognizable, and the terminology has been twisted and mangled beyond belief. However, if I must choose, I would say that DeepL delivered a translation slightly less atrocious than the one of OpenAI. So, the winner of this showdown, by the slimmest of margins, is DeepL. Both engines should hang their heads in shame for what they have produced here, though.
Whoa. No mercy, huh? I might have spiced things up a little with some additional request parameters about. I feel this is where the use of the API can really take things to the next level when compared to just using the default chat interface. You probably know about the temperature slider already, but did you also know that each request you send to OpenAI as a user can be accompanied by additional instructions from a system role, any conversation you had prior about a subject, and the AI's own responses? I can only recommend OpenAI's guide about user roles. Anyways, it's what I used to give OpenAI a bit of a fiery and sarcastic persona for this showdown. I still cannot believe that this actually worked. To reflect that in their tone of voice, I would also have to change the ElevenLab speech synthesizer steps in the automation workflow. It can be achieved simply by tracking the AI a bit and switching my prompt to third person. With that bit of extra context, it can make GPT-4 sound really upset.
I can't believe you would do this to me, man. This is really not okay.
Alright, let's dial things back again, shall we?
Agreed. Let's look at the final showdown.
We're back in the App Store, and for this last one I picked another game description, this time coming from workshop host Supercell. It's Clash of Clans, and this text here. This time we will give OpenAI some additional context about the type of text and our expectations for the translation. We will also give it a lot of freedom for creativity and go for 9 relay cycles, which means 50 translations in total. And off we go. I mentioned it wasn't about speed, right? Oh boy. How are we doing, GPT-4? Mind taking us through the results and crown a winner?
No problem. Let's talk about Skeleton Park first. DeepL dutifully rolled out the red carpet and welcomed us with Üdvözöllek a Skeleton Parkban, Hungarian for Welcome to Skeleton Park. While OpenAI went from spooky to more anatomical and turned it into Bone Park. It gives the park a slightly different vibe. Hey, who wouldn't want to visit Bone Park? In the realm of mysterious change in meaning, both engines had their fair share of blunders. The shovel of obstacles became Hindernis Paddle, obstacle paddle in German, and obstacle removal in the final translation. It appears that the AI decided to focus on the action of the shovel rather than the object itself. Well, form follows function after all. The super miner underwent quite the transformation, becoming Baufa Surusupamena, exploding superminer in Japanese, and eventually Super Bowler in the final translation. Maybe the AI decided mining would be too trivial of a concept, so it came up with a completely different activity. Bowling. Ingenious. Both translation engines also had a penchant for altering the original text's tone and focus. The mustachioed barbarians turned into cheerful mustached barbarians and later into fun-loving barbarians. Maybe the AI thought that their personality was more important than their appearance? After all, it's what's on the inside that counts. All jokes aside, I am sure you all agree we have a clear winner. Of course, it's OpenAI. It takes the crown for a couple of reasons. First, it managed to somewhat maintain the overall meaning of the original text, despite not holding back on artistic freedom when it comes to making content changes. Second, it demonstrated a strong creative flair in its translations. adding mystery and excitement to the text. For example, turning Superminer into Exploding Superminer made the character sound more dangerous and thrilling. OpenAI kept its translations fun and throughout, even though it strayed from the source quite a bit in the end. While it did manage to maintain its meaning, DeepL struggled to preserve any of the original text's humor and excitement, often simplifying descriptions in ways that made the text less engaging or just flat-out boring. OpenAI wins this showdown, showcasing its superior abilities to somewhat preserve meaning and inject personality into its translations.
I'm sorry, what? I'm beginning to think that you may be a little bit biased here.
And I think someone has maxed out his monthly OpenAI API usage limit. I am out.
Bye-bye. Well, so much for my assistant, I guess. The API project is complete anyways, though. After 3 test runs, we have confirmed that our API control translation workflow meets the project goal and allows for comparing the MT proficiency of ChatGPT and DeepL. And while the results of the performance comparison might be debatable, they do offer some fascinating insights on the machine's decision-making process while translating. I actually set up the Showdown as a web tool for everyone to conduct their own tests, but GPT-4 was right. I did, in fact, max out my usage limit already, so I had to disable the form. However, on the project page you can still access the detailed summaries as well as the complete translation data table for each of the 3 runs, which in the end had a volume of over 100,000 words. Over the course of the video, you heard me excitedly reporting on learning about API features I didn't know about before. I believe having those discovery moments is the biggest value to get out of a practical exercise like this. We might have used them only for fun here, but who knows where it will come in handy to know how to send API requests to OpenAI and how to receive and process the responses of these calls, how to send requests with Google Sheet cells as variables, and how to combine the OpenAI output with fancy new text-to-speech technology. I am also a lot more aware of the possibilities and limitations of OpenAI in general. I was very impressed by the scope of the machine's comprehensive capacities when using variables and tokens for dynamic prompt creation. Though OpenAI will definitely not outperform neural machine translation with the ChatGPT format, I was still impressed by its performance. Consider that DeepL was designed to respond only with translations, while OpenAI in this setup is essentially an amnesiac who has to understand with every new prompt that they are a translator now and you expect them to translate something. Instead of translating itself, though, I think short-term OpenAI could be integrated in our translation tools to offer consistency and terminology assistance, but also for helping with segmentation, as it can reliably produce regex filters simply by just talking with you about what you need. In the not all too distant future, I suspect that OpenAI will have learned how to use Machine Translation API itself, or even use multiple different ones at the same time and pre-select the best possible result. I'm really excited to see how developers will take this tech to the next level for localization. Before we call it a day, let me at least try to leave you with a wise concluding message by telling you about the API process that developed out of the requirements for making this video. For each video segment, I created an outline first, which was then formatted according to my default template and then sent to OpenAI for making it, well, somewhat coherent. After that, it was ready to be used for my voiceover on a service called Descript, which allows to edit video based on audio recordings and, similar to 11 Labs, also offers AI-driven text-to-speech functionality. Descript recently cheerfully notified me that it now had collected and analyzed enough of my recordings to fully synthesize my voice. In fact, I have never spoken the words of the last 2 sentences at all. Pretty wild, huh? RoboDaniel certainly creeps me out. So my message and personal opinion is this. I agree that there is a lot of potential for people abusing all this new API tech, for sure, but I think that makes it even more important for us to maintain a good level of general understanding of what they are capable of to achieve and what not. As localization professionals, we need to be able to ensure our stakeholders and clients that we will always provide them with the optimal solution for their actual use case, irrespective of the currently trending industry tech headlines. After making it through this little showdown adventure with me, I hope you agree that a bit of API self-study and on-hands experimentation can certainly help you to get there. If you want to share your experience, opinion, or have a question about any of the topics I talked about, feel free to post them in the comments. For now, happy tinkering and thanks for watching.